Well done. Welcome to this tutorial. In this tutorial, I am going to be showing you some things you can do in GIS. Actually, there are certain things you can do in GIS. Certain analysis you can do using certain formulas, which you can really do in ArcGIS. For example, let's run through this. This is land surface temperature, which is not new. I'm going to be showing you some things. Actually in Landsat images, there are certain minerals you can extract, and this information I got in from a reliable source. Now, this is chlorophyll index. That is a vegetation index for estimating the chlorophyll content in leaves. Now, this is it, which means that for this to be carried out, we need a very high resolution image to carry out this operation, and that is using the near infrared band divided by the green band. So, or rather, let's say if we use a Landsat image, it means we will need the near infrared band and the green band, but I believe we can manage to use a high resolution image. A high resolution image is needed for this. Now, this is another one, chlorophyll index, red edge. This is another one. Now we have clay minerals method. You can see shortwave infrared 1, shortwave infrared 2. That is for identifying mineral features containing clay and aluminite using 2 shortwave infrared. That is shortwave infrared 1 and 2. This is enhanced vegetation index. This is the formula for carrying out enhanced vegetation index. Now, this is ferrous minerals. This is global environmental monitoring index. You can see this is the formula for carrying that out. So that is to tell you that there are certain analysis you can actually carry out in GIS using certain formulas. This is green normalized different vegetation index. It's a vegetation index for estimating photosynthetic activity, and is a commonly used vegetation index to determine water and nitrogen uptake into the plant. This is one. So you use the near infrared minus the green band, then divided by near infrared plus the green band. Now this is the green vegetation index. This is another one. This was designed for Landsat MMS, that is multispectral scanner. Now you can see this is band 1 minus this, so 7 bands. And that is 5 bands. That is band 1, 2, 3, 4, 5, and 7. You can see. So now these are so many things you can really do using GIS, but you can see it requires you to use certain formulas. That is one thing about it. So it requires you to use certain formulas, and these are things you can actually do in ArcGIS using the raster calculator. So this is it. You can see. Now this is another one. This is another one here. These are other things you can also do. You can see sediment transport index, topographic wetness index, and this can be done using the DEM data, that is the data elevation model data of the area. You can see stream power index. You want to know the power, the flowing power of the stream. Then this is topographic ruggedness index to know the terrain. So this can be done using ArcGIS calculator, but there are certain analysis you need to do before you can derive at this minimum, the data elevation model maximum, and the smooth. Now, but today what we are going to be looking at is the RUSLE model. The RUSLE model is is presently being applied in GIS, but it's not that vast like that. And RUSLE model now is a model used for the estimation of, it is a widely used model for the estimation of soil erosion. You want to know the annual soil erosion loss, the rate of soil erosion. So that is what this factor is all about. So the model helps in it is a model for predicting annual soil erosion rates. It's a model for predicting annual soil erosion rates in a particular place. But before you do it, there are 5 basic things you need to know before you can actually determine the soil erosion rate of any region. RUSLE model, it has 5 things, it has 6 things you need to know, which the annual soil loss makes it the last, that is the 6th. The first thing you need to calculate when you want to perform a RUSLE model, you want to determine the annual soil erosion of a particular area, is the rainfall erosivity factor. Then the second thing you want to do is the soil erodibility factor. Then the third is the slope length and steepness factor. Then the fourth one is the land cover factor or the cover crop management factor. Then the last one is the conservative or management practice factor. Then the last one but not the least is the annual soil loss. That is the addition the multiplication of all the models. Now this is soil erodibility factor. It represents both susceptibility of soil to erosion and the rate of runoff as measured under the standard unit plot condition. Now this is it. That is, it is called the K factor. Soils high in clay have low K values, about 0.05 to 0.15. Now looking at this, you can also see the rainfall erosivity factor. That is, it shows how the amount of rain affects soil loss. Like if there is heavy precipitation, we have much soil loss than when we have low rainfall. That is what that one tends to determine. Now these are the formulas you can use. Lambodi method, where R is the rainfall erosivity factor, P is the mean annual rainfall. Then we also have another formula called the formula of NEPRO 1981. That is R equals to this. Then MX is the average monthly precipitation, YR is the rainfall. Then we also have a formula, another formula, that is the Val et al. Method 1986. This is the formula. Now this is the length of slope, and this is the step in calculating the length of slope. This is the steps in calculating the length of slope, and this is the final formula in calculating the length of slope after determining the flow direction, the flow accumulation, the slope map in degrees. Then this is the formula we use in determining the final length of slope. Then this is the cover crop management factor or the land use factor. Now this is the formula. That is Donje et al. 2014, adapted by Coleman. This is the formula. Van der Nijf et al. This is another formula. So now this is, you can use either of the two formulas to determine your C factor, which is the land cover factor. And the one thing about land cover factor is that after determining the land cover factor, the land cover factor is being determined using a particular method, and this method is being used like it is a general accepted C factor values. This is it. You can see it is a generally accepted C factor values, That is, water body is assigned a C factor of this, cultivated land is assigned this, forest land, and this you can see. So you can also find others. This is another one. You can see C factor range. That is forest range between this to this, grassland range between this, urban, which is the settlement range between this to this and that. So this can be applied to anyone. Once you determine the soil, the land use, land cover, so you do some, you reclassify and you apply these values. So that is a widely acceptable C factor range. Then we also have the P factor. The P factor, which is the management practice factor, that also has a widely acceptable value by Wishman and Smith in 1978. This is it. And it's majorly based on agriculture, which means that from the land use map, we are going to extract out only the agricultural area and now use the agricultural area to determine this. We are going to create a slope map. Then we are now going to apply this P factor based on this range of slope, but it's going to be for agriculture. We are going to extract out only agricultural areas from the land use map. Then we are also going to extract out other lands, so which means that we are going to convert the land use map to polygon, extract out agricultural area. Then after extracting agricultural area, we are now going to also use the other land. The other land represent the other classes, so the other land will now be given the range of this. This is a widely acceptable P factor values. So tonight we are going to start with rainfall erosivity factor. We are going to start from rainfall erosivity factor. But first thing I want you to know is that if you want to create a rainfall erosivity factor map, you need a rainfall data. You need a rainfall data for that area. So you need a rainfall data. So I believe I should have a rainfall data here. It should be, I believe I have a rainfall data that we can use for the analysis. Okay, let's make use of, let's see if there's any here. If there's no rainfall data, it means we are going to, okay, there's no rainfall data here, so we are going to make use of okay, let's see if there's a rainfall data here. Okay, there's a rainfall data here. This is a rainfall data of a particular place in Pakistan. This is the rainfall data of a particular area in Pakistan. You can see this is the latitude, this is the longitude, and this is the actual annual rainfall. This annual rainfall was downloaded from using Google Earth. And in our next tutorial, I'll be showing you how you can download the rainfall data from Google Earth, and now you can also download it from NASA. That is the US site. That is NASA. So we are also going to show you how to download it from NASA. So this is a rainfall data which we can use. So now we open ArcGIS. Then the first thing we do is we add our rainfall data. First thing is to add our rainfall data. So apart from that, we are also going to add the okay, let's download uh, let's see. Okay, let's see. So I'll be using this just for an example. So in this case, we are going to be using the map of Ibadan, for example, for the analysis. So here I'm going to bring in the um, Excel file of Ibadan. So this is it. So I'm going to add it. So and I'm going to also bring in the shapefile of uh, Ibadan. So now, okay, the shapefile of Ibadan. I'm also going to bring that in. So okay, this is it. So now I'm going to right click on this to display XY data. So I'm going to convert it to point. Here I'm going to select the annual rainfall. Then here I'm going to apply the geographic coordinate, and can you see these are the stations I picked? 1, 2, 3, 4, 5. So I picked these stations. So let's use those stations to create the rainfall map. So I'm going to right click on this to convert it fully to shapefile. So I'll select this. Okay, so rainfall. So now I'm going to remove this because I don't need it again. So now what I'm going to do now is to create a rainfall map, and to do that I'm going to go to my ArcGIS. So I'm going to go to Spatial Analysis 2, then I'll go to Hydrology, I will go to Slope, Surface, sorry, I'm going to go to Interpolation. So this is Qgis, so I can use Qgis, and I can use Inverse Distance Weighted, that is IDW. So let's use Qgis. So I'm going to input the point features. So here I'm going to select the annual rainfall. But there's one thing you need to do, which is very important. You go to the environment. You have to set the environment to be on the same extent as the map of Ibadan. Otherwise, it won't cover that extent. So go to raster analysis as well. So let's do that again. So we select Ibadan. So we also go to raster analysis as well. We'll scroll down, mask, select Ibadan, then we click OK, then click OK here. So and this is going to create the rainfall map. So let's see. Possibly we are going to use Qgis. So let's use the IDW. So let's use IDW to see if we can get a better result. So this is rainfall. I'm going to select the annual rainfall. So we are going to select the environment. Then we're also going to select this. Then we're going to click OK. Yeah, this is better. So now this is better. So now we are going to call this the rainfall map of the area. So we are going to right click on it, go to properties, so you can go to stretch. So this is the highest rainfall, this is the lowest, so we can give it a particular color. So you can see these are places with low rainfall and these are the places with the highest rainfall. You can see these are places with the highest rainfall. Now the next thing we need to do here is that we are now going to create the rainfall erosivity map. That is the effect of rainfall on soil erosion. So to do that, we are going to use the formula for rainfall erosivity. We are going to use the Lambodi method, or rather we can also use this, we can use the Lipron. So let's use the Lipron. Let's try that. Is mx is the average monthly precipitation. So let's use that and see what it will give us. So we are going to go here, go to map algebra, go to raster calculator. So here I will paste the formula here. So let me just say R equals to this, then this is the precipitation, that is our annual rainfall. So this is the annual rainfall. I'm going to put this there. So this is the annual rainfall, that is R equals to 0.13, then multiply by rainfall map into bracket this and this. So so let's try to see. We are going to do R. Okay, we are going to say 0.13 multiply by this. So let's say R equals to 0.13 multiply by 0.13 multiply by the rainfall map, then bracket open 1.24 bracket close, then 4. So we can remove this, can remove all this. So let's see. So let's see this. Let's see where the error is coming from. Okay, let's add another bracket here and see. So we're going to still look at it, where the error is coming from. This. So okay, that is it. Let's run it again. R equals to 0.13 multiply by the annual rainfall into bracket 1.24 bracket close, then space, Let's say 4. Let's see if that will work. Not working. So let's add a bracket here and another bracket here and see if it will work. Okay, now since this is not working, we are going to make use of the second formula, which is this, which is the Lambodi method. So we are going to make use of this. So I will paste it here. So here is the rainfall. So just click OK. So this is the rainfall erosivity map. This is the rainfall erosivity map. This is highest rainfall erosivity. This is the lowest. You can see this is the Lambodi method. So let's try the other method again, which is this. That is this. So that will be R equals to 0.13 multiplied by into bracket rainfall data bracket close, then multiply by bracket open 1.24 bracket close, then multiply by 4. So that is what's supposed to be here. That is what's supposed to be here. So once you've done that, just click OK. So it will calculate the soil erosivity, the rainfall erosivity factor for you. You can see this is for the first formula, which is the other formula, which is the April 1981. You can see what it's calculated as the highest soil erosivity, lowest. So you can see it's calculated the same thing but with different values. You can see this is the place with the lowest erosivity. So now if you change this, now you can see places with high erosivity. Now that is all about rainfall erosivity factor. In our next tutorial, we'll be going to the soil. We'll be looking at the soil erodibility factor. That is K factor. So in that area, we are going to be making use of the soil map of the world, where we are going to extract our information to determine the soil erodibility factor. So next tutorial, we are going to look at soil erodibility factor. Thank you.